All right, for our last graph, we're going to do y equals 2 to the x, and then we're going to use that to graph log base 2 of x. So starting out with y equals 2 to the x, we're going to do our xy table. -2, -1, 0, 1, and 2. So we're going to do 2 to the -2, 2 to the -2. Remember, when we do that to get rid of negative exponents, we have to drop it on the bottom. So this is 1 over 2 squared. So 1/4. 2 to the -1 is going to be similar, that we have to drop it underneath. So this is 1 over 2 to the first. The rest of them are easy. I'm not going to show work on that. 2 to the 0 is 1. 2 to the first power is 2, and 2 squared is 4. You know what? I think on this one I want to go one more because I can fit one more on the graph. 3. 2 to the third power is 8. So we'll graph this. -2, 1/4, -2 1/2, 0, 1, 1, 2, 2, 4, and 3, 8. And again, we have another exponential growth. Not quite as steep as our other two because 2 is smaller than e and it's smaller than 10, but this is y equals 2 to the x. Same things are true about this, is that the domain is all real numbers, the range is greater than 0. Also, I think we talked about this before, but not that. Oh, what was that? Sorry. There we go. These all have the same intercept. Okay, all of your exponential functions, as long as you haven't transformed them left or right or up or down, they're all going to go through the point 0, 1. So hopefully you've seen that. Okay, so now what we want to do is graph log base 2 of x. Hopefully you can see from the other videos that this is the inverse, because if we take y equals 2 to the x and we switch the x and y, x equals 2 to the y, and then we rewrite this in logarithmic form, this is log base 2 of x equals y, that's what we've got here. Okay, so this is the inverse of the blue one that we just graphed. So to graph this, we're going to switch the x and y that we have over here. Okay, so -2, -1, 0, 1, 2, 3, and 1/4, 1/2, 1, 2, 4, 8. So we'll graph these things. 1/4 -2, 1/2 -1, 1, 0, 2, 1, 4, 2, 8, 3. So here's what this looks like. Again, they're inverses, so it's going to reflect over this line, y equals x. Also, I don't know if you've noticed this, remember how all of our exponential growth goes through the 0, 1, exponential decay does too. But all of these exponential growth go through the point 0, 1. All of our logarithm functions are going through the point 1, 0. So let's kind of summarize what we have learned here. Okay. In general, any logarithmic function that you have, log base 10 of x, log base e of x, which is natural log base 3 of x, log base 4 of x, any of those, the general shape of them is going to be like this. Okay, it is the inverse of the exponential growth. Unless we've transformed them, they are going to go through the point 1, 0. Unless we've transformed them somehow, the domain is x is greater than 0, and the range is all real numbers. Okay, so remember we've had all of those parent functions that we talked about, like we know that linear functions are lines, we know that absolute value functions are v's, we know that quadratic functions are parabolas, we know that cubic functions look like this, except I missed that point. We know that square root functions look like this. Okay, these are all these parent functions we've talked about. I think I've got them all. Oh, exponential growth, we've learned, looks like this. So we have added a new parent function. Okay, in general, you should know the shape that logarithmic graphs look basically like this. So we're just kind of adding this to our pile of parent functions. So your homework for tonight is just going to be doing more graphing with this. And then we will talk about this more tomorrow.